This module addresses some of the installation issues inherent with data and telecom facilities. Due to the mission-critical nature of telecoms and data centers, special installation considerations should be followed. These account for faster transport times and incipient levels of smoke reporting. These areas usually have high airflow and as such are subject to dilution and other environmental factors. Some of the challenges are listed on this slide. This slide references code statutes relative to data and telecom facilities. These denote the different levels of coverage and their respective benefits. The Vesda VLC is capable of providing the best practice level of coverage as above. One of the benefits of the Vesda system is that additional sample points can be added without additional expense. Here is an example of on-ceiling coverage as part of the coverage solution. Capillary sample points allow for unobtrusive protection and are a direct way to put a sample point into equipment cabinets, for example. These allow for sample points to be added anywhere without an extensive pipe network. Sample point hole size is determined by Aspire 2. This is an example of capillary points installed in a drop ceiling. Here is another example of capillaries. These tubes can be up to 26 feet long, but understand, the longer that they are, the fewer you can have on a single pipe. Capillary tube length and hole size is calculated by the Aspire 2 software. In this underfloor example, the Vesda pipe is attached to the floor supports and the sample points are drilled into the pipe. This method allows for protection of the unfiltered air from the room and also protects the vast cabling typically found under the floor in such applications. These are some spacing considerations for sample point spacing versus airflow rate. This is one method of setting sample points into place below a raised floor. Another might be to install the trunk pipe onto the slab and tee up to the underside of the floor. In this example, the VLC is sampling the air before filtration occurs by the air handling unit. These holes should be angled as per the pipe installation module of this course. In that way, an even pressure is maintained at the sample points throughout airflow changes. These holes should also be angled. Raw airflow should be used as the benchmark to achieve proper hole angle. When monitoring raw airflow with VSC software, cycle the grill or air handling unit. The raw flow should stay about the same whether the grill is running or not. The number of sample points per vent are determined by code as in the slide above. The VLC can space sample points of 1 foot if desired without additional cost. This is an example of standoffs aiding in airflow consistency. If the pipes are too close to the vent, the volume increase of air lowers the pressure at the holes, causing inconsistency in measurement. This is another example of hole angling to achieve consistent sampling throughout the AHU cycling process. Dilution occurs when too many air sources are covered by the same VLC. Multiple air sources dilute the air sample, so therefore only one air handling unit per pipe is recommended. You can branch a pipe once for this purpose as illustrated. This example of dilution uses a 4-pipe detector to illustrate how to combat the dilution effect. The same theory holds true to the VLC. In-cabinet sampling is sometimes used in conjunction with other detection methods, return air, on-ceiling, etc. Here are 2 different ways to get sample points into the top of the cabinet, which is required. Here are further examples of sampling the air before filtration. These AHUs move a lot of air and have efficient filtration. They may remove a small smoke sample from the air, which is why we sample before air enters. Here is yet another example of equipment cabinet sampling. According to NFPA code, beam pocket protection may be needed. Here are two alternative methods to achieve this. Option 2 generally uses less materials and is more widely implemented. These pictures show the Vesda piping installed in a cable tunnel. The sample points cover the space at the beam level and J-hooks protect inside the beam pockets. Hopefully these examples have demonstrated the versatility that the VLC offers to protect these mission-critical sites. This concludes the Data and Telecom module of this course. These pictures show the Vesda piping installed in a cable tunnel. The sample points cover the space at the beam level and J-hooks protect inside the beam pockets. Hopefully these examples have demonstrated the versatility that the VLC offers to protect these mission-critical sites. This concludes the Data and Telecom module of this course.